Hello, class. Today we're looking at an algebra problem that's all about equivalence. We're given a starting equation, 1,4a equals b squared times c to the sixth, and three other expressions labeled with Roman numerals. Our task is to figure out which of these expressions are just different ways of writing the original equation. The best strategy here is to be methodical and test each expression one by one. Let's get started. All right, let's dive into expression 1. As you see on the screen, it is a equals the quantity bc cubed, all squared, divided by 14. Our goal is to simplify this and see if we can make it match our target equation, 14a equals b squared c caret 6. The first thing we need to do is simplify the numerator, which is bc cubed squared. To do this, we need our exponent rules. First, the tots power of a product rule tells us to apply the exponent to each factor inside the parentheses. So it becomes b squared times c cubed squared. Next, we use the power of a power rule for the c term. We multiply the exponents. So c cubed squared becomes c to the power of 3 times 2, which is c to the sixth. Putting it all together, the numerator simplifies to b squared c to the sixth. Now that we've simplified the numerator, we can substitute it back into the equation for expression y. This gives us a equals b squared c to the sixth, all divided by 14. This already looks very similar to our target equation. We're just one step away. To make it look exactly like the original equation, we need to get 14a on the left side. We can achieve this by multiplying both sides of our current equation by 14. This cancels out the 14 in the denominator on the right side and gives us 14a on the left. And there we have it. 14a equals b squared c to the sixth. This is a perfect match, so we can conclude that expression I is equivalent. Okay, 1 down, 2 to go. Let's move on to expression 2. This one states 14a equals the quantity bc to the fourth, all squared. The left side, 14a, already matches our original equation, so let's focus on simplifying the right side. Just like before, we'll use our exponent rules on the right-hand side. The quantity bc to the fourth squared becomes b squared times c to the fourth squared. For the c term, we multiply the exponents. 4 times 2 gives us 8. So the right side simplifies to b squared c to the eighth. After simplifying, expression 2 becomes 14a equals b squared c to the eighth. Now let's compare this to our original equation, which was 14a equals b squared c to the sixth. The exponent on c is 8 in this expression, but it was 6 in the original. Because the exponents don't match, these two expressions are not equivalent. So expression 2 is out. All right, let's check our final candidate, expression 3. This one is written as a times b to the negative 2 equals c to the sixth over 14. That negative exponent is the first thing we should deal with. Remember the negative exponent rule. X to the power of negative n is the same as 1 over x to the power of n. So b to the negative 2 is the same as 1 over b squared. When we substitute this into our expression, we get a times 1 over b squared, which simplifies to a over b squared. So the equation now reads a over b squared equals c to the sixth over 14. Now we have a proportion, which is one fraction equal to another. The easiest way to solve this and get rid of the fractions is to cross-multiply. We multiply the numerator of the first fraction, a, by the denominator of the second, 14. Then we multiply the denominator of the first fraction, b squared, by the numerator of the second, c to the sixth. After cross-multiplying, we get the equation 14a equals b squared c to the sixth. And look at that! It's another perfect match with our original equation. This confirms that expression 3 is also equivalent. So let's summarize our investigation. We systematically checked each expression. We found that expression I successfully simplifies to the original equation. We found that expression 2 does not. And we found that expression 3 also simplifies to the original equation. Therefore, the correct answer must be the one that says only I and 3 are equivalent. Looking at our options, that is choice D. And that brings us to our final answer. The correct option is D, as it correctly identifies that expressions I and 3 are equivalent to the given equation. This problem was a fantastic review of our exponent and algebraic manipulation skills. The key takeaway is to be systematic and confident in applying the rules you know. Well done, everyone!